can absorb as well as discharge. So bidirectional flow is possible. Fastest kinetic energy recharge. You know, in batteries, you could buy a 30-minute battery, but then to get it recharged, it takes maybe 12 hours, 13 hours, 14 hours, sometime even a day to get these batteries recharged, to be ready for your next power outage. Whereas these charging time, recharging time are less than minutes, 2 minutes, 3 minutes time. So we are talking about minutes here and not about half a day or maybe even a day. Simple design, just again, two bearings only, right? And low loss helium environment. This flywheel again rotates continuously 365 days, 24 hours. So in order to maintain the losses in the machine, you have a helium environment, and this helium environment reduces the losses of the machine. Very small footprint. You can see equivalent 2000 kilowatt battery system, how big it is compared to a flywheel which is as small as this, which can be put in a panel and vertically standing machine. Okay. Now here is a comparison between a power bridge or a kinetic energy storage against a battery. As I said, batteries require a very cool environment, but flywheels or power bridge doesn't require a cool environment. So ambient temperature 0 to 40. What does this mean? You don't have to have a cooling equipment. You don't have to spend energy in cooling every day. So cooling expenses are very, very high in a data center. So you don't need cooling for these batteries. The footprint for a 500 kVA 10-minute battery system is 4.5 meters square, whereas a flywheel is just 3.6 meters square, which is almost 30% lower than a battery requirement. Expected lifetime. Okay, here we have put 8 to 10 years. 8 to 10 years are the most premium batteries available in the market, well maintained at 20 degrees or 18 degrees temperature. Whereas in general, when I visit many of my customers, they always say they replace their batteries in 3 years' time or 4 years' time. So you can imagine, here we are talking about a 20-year lifetime with no degradation, right? Whereas batteries degrade by time. Here you have a 20 years lifetime with no degradation of your power. The storage still remains the same, right from day 1 to day 20. No difference. Green factor recycling is very high. Here is low. Additional air conditioned power is very low. You just need some cooling air, circulation of air inside the room. Highly additional operating expense. Aging effect, there's none, whereas here is approximately 5% per year. Maintenance effort is low. You only change the bearings, whereas here you have to replace the equipment itself. You have a lot of maintenance equipment to look at it. And highly, one more factor which I have not mentioned here, batteries are the most unreliable equipment in any data center. If an analysis was done by Emerson last year, and according to the database, it was almost like 55% of the failures in any data center are attributed to battery failures. So with this power bridge, you don't have any failures at all. Okay. Of course, the efficiencies are high. We've already seen that. And you can see that this is the pillar UBT plus rotary UPS, whereas a leading static UPS, these are the efficiencies. At 50%, also you have a very high efficiency. Most of the data centers operate at 40 to 50% the load. So even with that particular load, the efficiencies are very high. And as you approach a higher load factor, the efficiencies are much better than static UPS. Okay. Yes. Now we have to look at, after efficiency, we have to look at the reliability, the probability of failure of these UPS. Okay. In a static UPS, what does it consist of? It consists of these switching devices, which is called an IGBT. Okay. IGBT switches at 2 kilohertz. 2 kilohertz is a very high frequency of switching. So when a switch, any particular switch which keeps on operating, there's a very high possibility of it to fail. And then capacitors also charge and discharge every time. And due to that, there are a lot of failures of capacitors. And battery, of course, is charging and discharging. So if you look at all of those parameters, A static UPS and mean time between failure is roughly 150,000 hours. This could be a very high, good quality static UPS, and you have a reliability or a mean time between failure of 150,000 hours. Whereas an MTBF for a rotary UPS is 1.8 million hours. 1.8 million hours. There's a huge difference in the time between the failures because the component used are less. Okay, there are no static components, there are no switching components. So due to that, the reliability of these components are pretty high. Okay, here is the comparison of a failed static UPS and a failed UBT in years. Okay. After 10 years of service life, almost 45% of the static UPS would have failed, right? However, an equivalent figure for a diesel UPS is less than 8%. So that shows how high the reliability of these UPSs are. Okay. I talked about space. Okay, reliability, efficiency we've seen. I also talked about space. So here is a comparison of how would a static UPS configuration with genset look like compared to diesel rotary UPS. So here's the static UPS. Okay, we don't cool the static UPS. Static UPS are capable of running at 40-degree ambient temperature. Okay, batteries are at an ambient temperature of 25 degrees Celsius. So here's the static UPS configuration for a similar capacity, and whereas for a diesel UPS, you can see what is the difference of space that is required for the same capacity of UPS. Okay, whether it's a diesel UPS or a rotary UPS with genset, still the space is almost like 55 meters square. Okay. One thing I forgot to mention to you, in a static UPS, you still need a genset room for permanent power. So this is the genset room for your permanent power, and this is your static UPS requirement for keeping the reliability of power. If you change this to a concept of a UBT plus with a genset, this is the total space that you require, including a genset and the rotary UPS. So you have almost 56% space saving by moving to rotary UPS with genset. We have touched on this topic about maintenance. The only maintenance that it requires is the bearing. All right. So you don't need very heavy maintenance, right? No capacitor change, no battery change, only bearing. Now coming to ownership cost. You might all think, okay, with a rotary UPS, huge equipment, am I going to pay much more? But the answer is no. This chart clearly says, okay, this is a UBT rotary UPS with an IP bus system. This is a static system redundant system, and this is a UBT with a system redundant configuration. 3 different configurations that we compare. First is the day one investment cost. Okay. Second, here the green color is the cost of electrical losses, and third is the cost of maintenance overhead. So you can compare this particular chart here. The ownership cost of a static system redundant is very high compared to a UBT system redundant, similar configuration, a UBT with system redundant. And if you go to other configuration, which is IP bus, it's much, much lower. We are there in the 6th floor. Later on, you can come and understand a little bit more about these different configurations and systems if you would like to know. Okay. Now, having introduced the rotary UPS concept to you, the only small variation here is the diesel rotary UPS, right? A rotary UPS can be used with a genset similar to a static UPS, whereas to save more space, to save the number of generators, we combine these two together and provide you a diesel rotary UPS system. Okay. This is a diesel rotary UPS system. The diesel engine, the uniblock which was vertical is now horizontal, and coupled together with the diesel engine. Here is the flywheel and the switchgear. Everything else remains the same. The power capacity is the same, the voltage levels are the same, okay, and the reliability of the machine is the same. Okay. The advantages, here again, the flywheel or battery is able to be used. It can be a low voltage or a medium voltage configuration. You can parallel maximum up to 40 megawatt of UPS. Okay, in low voltage UPS you can maximum parallel up to only 4 megawatt of UPS, whereas in medium voltage configuration you can parallel up to 40 megawatt. Space saving and no need for additional gensets. Okay. So what are the components here? That's a diesel engine. This is a diesel control cabinet. You have the uniblock, a motor generator, flexible coupling, a mechanical overrun clutch, base frame, vibrating pads, anti-vibration pads. Okay. This is a time chart of how the operation of this diesel rotary UPS happens. So this is your mains. This is your mains. Okay. So you have a disturbing mains. Either it could be a very short-term failure or a little bit long failure. Okay. And this is the flywheel speed. All right. The UPS output voltage, and the diesel speed. Two things that you have to note here, okay? There's a failure here, a short-term failure, and this is a bit long-term failure. In both these cases, the flywheel starts to discharge energy. The flywheel starts to discharge energy as you have seen here. But this particular outage is too short that you don't have to start your diesel engine. You don't have to start your diesel engine. The flywheel covers and then it starts to recharge again and then be ready for any outage. Whereas this particular outage is a bit longer, that the diesel engine has to start, take the load. While it takes the load, the flywheel is again charged completely. And once the power is back, the diesel engine is stopped. So this is a simple timing chart of how the diesel engine works with mains failure, how the power bridge discharges and charges. This is an historical chart here which shows the failures of power supply. May not be applicable to Bangladesh, but globally this is applicable. Almost 96% of the failures of grid are less than 3 seconds. 96% of grid failures are for less than 3 seconds. Only 4% of the grid failures are longer than 3 seconds. So if you're able to have a system that can withstand this 3 seconds by not starting your diesel engine, your overall operating cost is much, much lower. So that's the concept behind the flywheel that Pillar has, so that it can extend, so that you can extend the life of your diesel engine and you're able to maintain it at very low cost. Okay. And this particular advantage is very, very unique only to Pillar and not to our competitors because of the technology that we have, because of the flywheel that we have. Okay. Okay. So if you see here, the number of this shows the number of diesel starts with Pillar as against a diesel start with a competitor's similar diesel rotary UPS system. So Pillar's diesel rotary UPS system starts less, thereby giving you an advantage on the overall maintenance cost. This is an example of a distribution center. I'm not going to go into it. I just have less than 4 minutes. Somebody alerted me. I have less than 4 minutes time. So I'm not going to go into the detail of this. But any particular system configuration can be replaced with a diesel rotary UPS system. Any particular system configuration. Okay. So you can have a diesel rotary UPS here on a 2N system. Okay. You can also have a diesel rotary UPS on a container system in order to save space, save your construction cost, and to deploy it much easier at any time, anywhere. Some of the installations are on 10th floor of the building also. You have such big containers located on the 10th floor of the building. Okay. So this is a very important slide to compare the coverage area of a static UPS against a rotary UPS system. All right? So these are the criteria which UPS have to meet. Okay? Static UPS covers from here up to here. Okay? Whereas a UBT plus system or a diesel rotary UPS system covers all the way from here up to here, including very high efficiencies. These are some of the references that we have. This is an installation at one of the Spanish bank. Okay, here you have 5 numbers of UBT, which is 1670 kVA each. So total is 8,350 kVA in parallel. Okay, this is how the configuration is. A side and B side is being served by 2 IP rings. So you have 2 separate sources there. This is another data center in US. Pillar has supplied more than 270 MVA of power for one single data center with 7 different locations. We have supplied more than 270 MVA power of UPS to a single customer in 7 different locations. Okay. This is another data center in the US. Okay. So now coming to a last slide about pillar references in this particular in Asia. So if you see here, we have similar systems installed in India, more than 152 systems. In Singapore, around 35 systems. Taiwan, 126 systems. China, 120 systems. Korea, 350. Malaysia, 100. Thailand, 50. Indonesia, 10. Japan, 60. I believe after this summit, next time I can also include Bangladesh and say we have some systems sold by the next summit when I visit next time to Bangladesh. Yeah. So that's about my presentation. Thank you very much. I'm able to take any questions if you have. Thank you for patiently listening. Thank you. Okay. If there are no questions, you can come and see us on the 6th floor anytime. So my colleague and myself will be able to help you with any of your questions. Thank you.